We're gonna solve differential equation dg dt equals g squared minus 9 cosine of t. We're gonna solve this problem using partial fraction methods or partial fraction decomposition. First, we have to integrate. In order to integrate, we need to have t is one side and then g is another side. Let's have t's on the right side and then g's on the left side. So we want dt to be on the right side. To move dt to the right side, we gotta multiply both sides by dt. Then if we do that, then from the left side, dt and dt, they cancel each other out, and then we have dg equals g squared minus 9 cosine of t dt. Now we want g squared minus 9 on the left side. In order to do that, we gotta divide both sides by g squared minus 9. When we divide, we have to be careful here. G squared cannot equal 9. If thus, that be 9 minus 9, that will give 0. That will give us 1 over 0. We'll be dividing by 0. Dividing by 0 is undefined. We are not allowed to do it. That is the only thing we have to be careful here. Then from the right side, g squared minus 9 and 1 over g squared minus 9, they cancel each other out. And then we have 1 over g squared minus 9 dg equals cosine of t dt. Now we're gonna integrate both sides. Now if we look at the right side, we have a cosine of t. If we integrate a cosine of t, we got sine of t plus c. Now let's look at the left side. We have 1 over g squared minus 9 dg. We can try u substitution. That is u equals g squared minus 9, and then we take a derivative of both sides, and that gives us du equals 2g dg. And this does not match the form we have here. Here is where the partial fraction method becomes useful. That is a over g minus a plus b over g plus b. What we're gonna do here is we're gonna take 1 over g squared minus 9, and then we're gonna try to put in the form of a over g minus a plus b over g plus b. So we're gonna take the 1 over g squared minus 9, and then we're gonna factor the denominator. Once we factor the denominator, we have 1 over g minus 3 times g plus 3. Now we're gonna take this, we're gonna set to sum of a over g minus 3 plus b over g plus 3. In order to clear the denominator, we have to multiply by g minus 3 times g plus 3, and that clears the whole denominator. Now we have 1 equals a times g plus 3 plus b times g minus 3. This is a system of linear equation. What that means to us is that we can take 1 equals a times g plus 3, then we pick value for g. We're gonna pick 3. 3 plus 3 is 6, so that gives us 1 equals 6a. Then we divide both sides by 6, and that gives us a equals 1 over 6. And then we can do the same thing for b. 1 equals b times g minus 3. Then we pick value for g. We pick negative 3. Negative becomes negative 6. So that gives us 1 equals negative 6b. Then we divide both sides by negative 6. and that gives us b equals negative 1 over 6. Once we have value for a and b, we're going to plug back into equation, and then we're going to integrate that part. I do have case here, case g equals 3, g of x equals 3, g prime of x equals 0, plugging into differential equation, 0 equals squared 3, that is 9, 9 minus 9 is 0, 0 times cosine of x is 0, so g of x equals 3 is a solution. In case g equals negative 3, g of x equals negative 3, g prime of x equals 0, plugging into differential equation, 0 equals square negative 3, that is 9, 9 minus 9 is 0, 0 times cosine of x is 0, so g of x equals negative 3 is a solution. Now here's what we have once we plug in value for a and b. We have 1 over 6 all over g minus 3 minus 1 over 6 all over g plus 3 dg equals sine of t plus c. Now we can integrate the left side. Now once we integrate the left side, we have 1 over 6 ln absolute value of g minus 3 minus 1 over 6 ln absolute value of g plus 3 equals sine of t plus c. Now we can solve for g, but I'm just gonna leave in explicit form. This is one of the way that we can use partial fraction method.